needed to share this before we just kick off. Yep. Now, I want to say welcome to the Eco Carbon Exchange business webinar on managing construction sector emissions in an emerging economy. What we are doing today is getting deeper than just climate conversation that has been happening around. And so I want to first of all appreciate our panelists, our speakers and panelists, who have graciously accepted to be on this conversation. It was meant to be very robust conversation, global conversation, but also found that it's also a dry area for many people. It's purely to many something either you're in business or you're in academics. So we are using this as the first call to engaging in similar conversations because we know infrastructure is deep in terms of costs and in terms of emission. And so I want to appreciate Professor Austin Chike Otebolu, professor at the University of Lagos. Prof, you are welcome. I hope you are unmuted.
Thank you. Are you hearing me?
Okay, I can hear you. Prof, you're welcome, please. We appreciate you.
Okay.
Thank you. We've been on to try to get Dr. Chant, but it doesn't appear that will work to this moment. But we also have graciously also on panel, Dr. Tiwala Adeni, an environmental specialist. I think this is about the second or third is actually coming on our conversation. He's shown a lot of expertise and experience. And regarding what we're talking about today, even though it's a dry area, he has a lot to offer. Dr. Giwa, you're welcome. I hope you're on.
Yes, I'm on.
Very good. Thank you. Thank you.
Yes, thank you very much. Yeah.
We also have Dr. Teslim. I've had things to do with being for a long time, since I started on this course of emission issues right from 2015, 2016. And I know that being has a lot to do with building low carbon structures. And we are very glad to have Dr. Teslim Giwa as one of our speaker panelists today. Dr. Giwa, you're welcome, please.
Thank you very much, Innocent. It's a pleasure being here.
Thank you. Thank you. I'm very grateful. We are grateful. And like I said, very dry area, we have seen interest, across many operators, many actors in this sector. And so we are going to go straight on to the conversation. We're going to be allowing our panelists to give us, short few minutes to talk about themselves beyond what I have just said, their expertise, their exposure, and how they see the conversation we are exciting today, maybe in the run of time, in years to come. I will start with Professor Otebolu. Prof, can you just say a little words to people out there and about yourself?
Well, as you mentioned, my name is Austin Otebolu. I'm Associate Professor of Fiscal Management, University of Lagos. I'm a specialist in environmental valuation and sustainability and investment analysis. I'm going to talk to you today on reducing emissions in the construction sector of an emerging economy. I've published a lot of papers on climate change, sustainability in the built environment, and so on and so forth. So I have more than 40 years of teaching experience and 40 years in the industry too. So I have a combined experience, both industry and academic experience. Thank you so much.
Thank you. Thank you. That would be enriching. Dr. Adeni, talk to us again.
Okay. Good afternoon again, everyone. Yes, I'm Dr. Tiwalade Adeni, actually an alumnus of University of Lagos. So, Prof, I was once with you. I got my PhD from the Department of Botany. So I'm a core environmentalist. I've been in the academia. I've also currently I've been in consulting, and I currently lead a financial services institution on sustainability. So I'll be talking about the approaches to reduce emissions in building and road construction, and I'll be bringing some academic as well as professional insights into things that are actually practicable, not just research. Yeah. Thank you very much.
Thank you. Thank you. It would be nice if we have all our videos on so we can see ourselves. Dr. Giwa, let's also hear you.
All right. Thank you, Innocent. I'm Teslim Giwa. I work for the Foundation for Partnership Initiatives in the Niger Delta, also known as PIND. PIND was set up in year 2010 by the Chevron Corporation to provide, to support socioeconomic development in the Niger Delta. I'm a trained architect, also an energy efficiency expert. I trained at the University of Sheffield, where I got my PhD. I've worked in the built environment consultancy for over 15 years now. I also worked in the academia. I used to be the head of department of the Department of Architecture at the University of Ilorin. I'm keen around anything that has to do with property technology, renewables, the built environment, green buildings. And I'll be talking to you about, we've done it in PIND. We have a living building, which sort of illustrates the efforts at reducing emissions. So I'll be talking to you about from the perspective of somebody who has done it before. Thank you.
Thank you. Thank you, Dr. Giwa. I'm really excited that this conversation is coming on because we have loaded, panelists from both the academia and the hands-on, the field experience. So for us to start off now, I just want us to look at what encouraged us to look in this area, however dry it has been. So just a few slides as an introduction to the webinar, and then we can get on. Now, we looked at the public sector infrastructure related issues, and we know that it has been, a flogged sector in the sense that funding has been challenges to it. But it becomes an additional challenge as well because apart from funding, it's also, in some ways, the ones we've been done are creating enormous environmental challenges to it, looking at roads and buildings. And then we looked at, for instance, Nigeria's 195,000 kilometer road network, 60,000 of that are paved roads. And these are the ones that actually create the environmental challenges. We also have a need of 7,000 housing per year in Nigeria. We realize at just about 100,000, which means just 14.28%. If we're going to go optimum, we're going to be creating massive environmental emission issues, which means that if we're actually going to be going towards 20, 25, 30% and all that, we need to be ready to make it environmentally friendly. And we also find also that Nigeria's infrastructure stock is just about 25% of the GDP. And international benchmark has been that countries should strive to get 70% of infrastructure stock, 20% of 70% of GDP as the infrastructure stock. So we have 50% deficit already, which means every government that is going to come on is going to be striving towards closing that gap. Now, so we dive further into the emission issues in construction. I know that we have experts who are going to be talking to these issues as we continue. Now we look at the materials: cement, bitumen, asphalt, petroleum, products, and then the operations itself, the mechanized operations, and then power and all of those who are part of what constitute whether all the built environment, whether it's roads, whether it's buildings, and all of that. And when we check the emission, impact of some of this, we find that the California, the California bearing ratio of some of these documents, inputs like cement, okay, for first grade cement surface strength is about 40%, okay, which means a lot of cement has been used into it, and that is generating about 865 kilogram carbon dioxide per ton of that input. And for cement 2, it's about 10%. Now, if you use cement 2, even though it's going to be generating 650 kilogram carbon dioxide equivalent per ton, of course, in our own environment, which is tropical, you can be sure the road will be, the building, the pavement will be breaking down quite often. We also look at materials such as hydraulic road binders, and we found their levels of emission input. And that tells us that, see, a lot is being generated from that sector. And it made us to say, okay, can we start talking about this issue? Look at quicklime, for instance. Quicklime is 1.052 ton of carbon dioxide equivalent per ton of this material. So you see, generating heavily into the environment. And nobody is actually talking about this. You look at also others like the slag, like limestone, these are heavy emitters into the environment. So we are really happy that we are stoking this conversation at this time, which I know professional bodies essentially will join us subsequently to begin to talk about it, like Nigerian Society of Engineers. We made efforts to reach them. We also made effort to reach Nigerian Institute of Quantity Surveyors and estate valuers and all of that. I'm sure that this is going to, enable them to come in subsequent. Finally, we looked at total emission. In some of the cities, road generation 6 kilogram carbon dioxide per meter square per year of emission, and these are secondary roads. And it could reach upwards of 1,100 kilogram carbon dioxide equivalent per meter square per year for primary roads. Now, these are major. These are heavy. And you see, in cities especially, you'll find a lot of massive, heavy construction that being done. For instance, in Lagos, the road being constructed basically with cement by Dangote, should be classified in this level of emission. Also, earthworks, okay, generates its own emissions. Pavements, when it is done with bitumen in asphalt, okay, any bitumen in asphaltic concrete, this is the quantity 0.672 ton carbon dioxide equivalent per meter cube of space. Okay, this is heavy, if you ask me. And then if it is also a pavement that has aggregates in asphalt, is 16 kilogram carbon dioxide equivalent per meter cube of space. This is really eye-opening. So, and then when you look at construction activities, all the things that have to use equipment and machinery, they are also creating their own. For instance, in operations phase, we find 94 to 98% of emissions are within that period because they use energy, they use diesel, okay? And then vehicular movement, street lightings, and all of that. These are very serious contributions. And then the construction phase basically, comes in with its own little emission. The equipment themselves, 15 to 70%, depending on the equipment you're using. And then the rest of the materials, which we have stated earlier. Now, having said that, it gives me really a good an ambience environment to say that we have good speakers who are going to talk to this. So I'm going to be inviting our first speaker to now give us his speech or his presentation on this event, and that is Prof himself. Professor Austin Chike Otebulo is going to give us a presentation, reducing emissions in the construction sector of an emerging economy. We want to assume we are emerging, okay? We want to move beyond developing to emerging, and want to hear his perspective. Prof, you have the floor.
Okay, let me share my.
Okay.
I want to share my screen now.
Yeah, go ahead, sir. Share.
Okay.
Can you? Can you share?
Yeah, I'm doing that now.
Okay.
Yeah, in doing my presentation, I need to do a little background introduction about the sources of emissions in the construction industry. Basically, what makes us to be interested in this topic is because of the harm it does to the environment, both health-wise and the productivity of the people who live in the city, in the country. There have been a lot of research and publications on emissions. In 2009, the FID predicted that climate change could result in loss of GDP of between 6% and 30% by 2050, and that could be translated to loss of almost 100 to 150 billion naira in Nigeria if we don't adapt a more sustainable policy to control emission. The construction industry, building emission is about 50% of the carbon emission that causes climate change. And in the construction industry, emission comes in different forms, both in the production of the raw material for producing construction building, like cement, paint, blocks, and all these things. All these things use fossil energy, which transmits carbon. For instance, let's look at the cement manufacturing industry, where they use limestone and other things. There's a mineral side of it, where they have to excavate the mineral, the limestone for cement production. That uses fuel energy, that emits carbon at a very large level. Then the cement factory itself is under place of carbon emission. And the funny thing that most of these industries don't have any environmental policy or environmental units to manage and regulate the level of emission of carbon in their place. So, and this puts the life of the workers in danger. And we know that health is wealth. And when people are not healthy, it will automatically affect their output in the industry. So equally, when we have produced this raw material, we have to transport it to the site, either where it's being sold or where it is being used in the construction site. The vehicles that transport it have their own emission. They emit carbon monoxide, carbon dioxide, and all these things affect the environment. Likewise, the coordinator has already said the quantum of emission that goes by using concrete, iron and steel, asphalt. I don't want to belabor you with all those things. These are things that are happening. And the problem we have that there's no policy on the kind of material that will help the environment. Everybody is allowed to use whatever he wants. What the architect designs, what the social engineer provides in the design is what is. But if there's a policy of government, say, don't, this is what you use in construction or of roads and so on and so forth, that is try to embrace environmental friendly materials for construction. Let us look at building industry, for instance. The materials we use are not environmental friendly. We use steel, we use concrete, and so on and so forth. But if you can start using like EPS, expanded polypropylene, and a little bit of concrete and mild steel to combine them, and then brick, all these materials that don't emit much carbon will help us in the long run. There's no doubt that construction industry contributes significantly to greenhouse emission at different levels during manufacturing of building materials I mentioned, transportation, construction, and use and occupation of computer development. The construction sector is responsible for the use of 40% of global energy, 25% of global water, and 40% of global resources emitted to the atmosphere of the world, and contribute to 1/3 of the world's global house gas emission. During the construction phase, about 6% of the world electricity is consumed. Inefficiency in the use of energy will gradually degrade the quality of the environment globally. Carbon dioxide gas emission is triggered by energy released during the building life cycle, starting from the production stage, construction phase, operational phase, and demolition phase. The end of the building life is and contributes to nearly 50% of the carbon dioxide emission released at the atmosphere. To the atmosphere. There's no doubt that construction emissions have adverse effects on health of individuals that live in the vicinity or the country. When health is affected adversely, aggregate output in the country will be reduced. This is in tandem with the saying that health is wealth. Without good health condition, it will be almost impossible, if not totally impossible, to undertake any meaningful economic activity. The level of emission into the atmosphere in Nigeria is a result of construction activity, and it's a sort of major concern in the society. I mentioned road construction, the carbon that goes from road asphalt, using concrete in construction of buildings, using concrete material, iron and steel. But iron and steel, during the production of iron and steel and the construction level, it emits carbon. The last cycle of building provides an organized pattern of connection between the built environment and global climate. First, at the predominant level, where we clear the forest, at that level, we destroy the carbon sink which the forest provides. This stage involves the use of conversion of virgin land into a variety of activities connected in the destruction of carbon sinks. The forest. Next is the operation stage. This is operation stage, the most active life of the building. Energy is at the peak at this stage, as household activities rely heavily on fossil fuels. Electricity, you find out most people still use filament bulbs, which releases 90% energy. Only 10% of the energy in bulbs produces light. The remaining 90% produces heat energy, which heats up the environment, and carbon is also goes with it. The same thing with the facilities we use, gas cookers, cooling facilities and heaters in the countries where that are in cold regions. So all this use for electricity and household appliances that are carbon and energy intensive. Energy is also consumed during the demolition and reconstruction stages of buildings. Carbon dioxide is the most important greenhouse gas and the primary substance responsible for global warming and hence climate change. Any attempt by anybody to mitigate emission in the construction industry must pay special attention to carbon dioxide emission, among others, as it is the center of climate change. It has been observed by climate change experts that the manufacturing industry, transportation of building materials, and the construction of building consume a huge amount of energy with consequent emission of large amounts of carbon dioxide, which have negative effects on the citizens and their health. in order to address the challenge of carbon emission, particularly in Nigeria, there is need for an environmental policy targeted towards elimination of carbon emission through the use of eco-friendly building materials. Like suddenly there's a study that came out recently that bamboo have more tensile strength than steel, and that could be used for reinforcement instead of iron and steel. And I believe that bamboo will have less environmental effect compared with steel, which we use today. Some people use EPC, standard polypropylene, with mild steel and small concrete, which usually reduces the quantity of concrete we use in construction. All these things will reduce the level of carbon emission in construction industry. This will involve provision of emission monitoring and management and awareness creation among the citizens. But if you say we are trying to control emission, there must be a monitoring management system. The people we are aware of the danger of the havoc caused by carbon emission to the society and its danger to the escalation of climate change. This will include also carbon rating. We don't have carbon rating. If you have carbon rating, it will give businessmen and industrialists the incentive to reduce their carbon emission. If you are given carbon credit or carbon rating, that if you emit this type of, if you reduce the emission by this level, you get this level of carbon credit, and that will encourage users to reduce the carbon emission in their enterprise or their behavior. Every mature industry must have an environmental department which should be drawn from national policy. So every mature industry must have an environmental policy which should be based on the national environmental policy, which we don't have as of today. But this will lead to carbon management strategy if there's a policy that will encourage people to control the level of emission and how they use environment. In Nigeria, nobody cares about the environment. Everybody does what he likes. The Ministry of Environment that are supposed to take care of this situation seems to be sleeping about it. They just make noise and there's no policy, there's no standard, there is no green standard in the country. No energy standard. Imagine the use of high energy consuming and carbon emitting building materials and embracing the use of more environmental friendly building materials. Reducing the use of fossil fuels in building construction. All this will help to reduce emission. Carbon rating buildings constitute the most pronounced tools being used in recent times by real estate professionals in countries like UK, US, and Canada, which is still lacking in our country. And it helps to reduce maintenance costs of buildings. Adoption of green standards for property development will help us to go a long way in reducing emission in building building operation, considering the fact that green buildings are associated with energy efficiency and low carbon emission. Energy demands within and around buildings is consumed mostly for the purpose of heating, cooling, lighting, and ventilation. Features of green buildings imbibe high-tech and modern energy saving practices like sensor control lighting and compact fluorescent and energy-saving lighting. High efficiency heat pumps, geothermal heating, photovoltaic cell arrays, and optimal use of fresh and natural light, harnessing natural circumstances for cooling and installation into design to reduce energy requirements in buildings, in building operation, and prevent greenhouse gas emissions from disturbing the environment. This is from Commission for Environment and Cooperation. The green buildings focuses on increasing the efficiency of resource use, such as energy, water, and material use, reducing the impact on health. And then the impact on health. And so if you show that in Nigeria, we are still yet to embrace this issue of green buildings. So currently, there are about 6 or 7 certified green buildings in Nigeria, and they are all located in Lagos, in VI and Ikoyi. And only 7 of them are certified, and they are all commercial buildings. Currently, there is no certified green residential building in Nigeria. And from the construction industry, in the building sector, residential building emit the highest level of greenhouse gas emission, have the higher level of greenhouse gas emission, which is a major problem. So we have to look at having a green standard policy. In US, they have the LEEDs. This is leadership, the environmental and development. In UK, they have the BREEAM. In Canada, they have other different countries have their own standards. In Africa, it's only South Africa that are already embraced green standard and sustainable environmental policy. So we need to actually have a policy that will help us to control the green emissions in Nigeria by having a green standard in buildings, environmental policy that will guide industrial operators for how they emit carbon and other emissions that are not friendly to the environment. We cannot allow everybody to do whatever he likes. That becomes a society that is not organized and prepared to anarchy. So Nigeria as a country is yet to develop adopt green standard as a policy tool for governance in construction industry. So we need to, as a summary, we have to look at the material we use. They have to be eco-friendly, that we have less negative impact on the health of the society. We have to introduce carbon rating. We have to introduce green standards. We have to embrace more environmental friendly materials in construction roads, in construction industry, and there must be regulation guiding industries on carbon emission. And there must be a minimum level or a maximum level of emission that should be tolerated by industries in the construction sector. Without this, it will be anarchy in the construction industry. So we need to have a policy that will guide us. But if there's no standard, then this result is chaos. So we have to standardize our construction industry in terms of environmental policy and the energy standards, including carbon emission. Thank you all for your attention.
Thank you, Prof. That was heavy. You know, the points you've made resonate quite well here, especially with respect to carbon policy, you know, by companies themselves, even construction policy by the country itself, implementing those you know, the policies. So it shows that we are still basically far behind adopting what global best practices that exist around the world. I hear when you also listed all the issues that create emissions, you know, in this sector. And then particularly what sticks out is even when you have to reduce forests, like what we had in Cross River some time ago, where a highway was to be constructed and a whole lot of carbon sink was to be removed because of you know, the trees that were to be brought down. And so it's very important. And then the energy that go with it, they go with the construction sector. There has to be a way of ensuring that this amount of energy is reduced, so that when we are doing baseline quantification for any such growth projects or building projects, we should be able to say, okay, from where we were going this way, this building has mitigated or has really reduced or saved the emission from the business as usual. Very, very important. Also, looking at solutions, the mitigation is essentially getting manufacturing industries to first create environmental policy that they are practicing, that they are actually implementing. It's not just for the sake of having it hanging in the front office there. And again, the issue of reducing the use of iron and steel in our construction, in buildings, for instance, and replacing with bamboo. I think this is something that should leave research desk and get into industry, so that it could be used into the by builders themselves into the industry. And now carbon rating is very critical. In fact, that's where a carbon exchange hopes also to midwife or catalyze practices there. Because if we're able to ascertain the baseline before a construction happens, and then we'll be able to see what measures have been implemented to ensure that emissions are saved from what would have been in business as usual scenario, then we can say this project, look, you are entitled to certain credits, and that could come down as part of what that company or that construction will earn again when such emission savings has been traded on the exchange. That is very, very important. And I see it very, very clearly. Now, the whole lot of things, I cannot go summarizing what you say more than what I have done. But again, having to also get green standard, we need to also follow the global practices and get green standard. Even if we just a starting point of the standard, I mean, as in the lowest to the minimum, or even you have to go to the 7 buildings we have in Lagos and say, oh, how can we, get more of this? We know it can be expensive, but again, I'm sure that when we increase the numbers, the cost will begin to come down, which is what has happened to, the global sustainability costings. Thank you again, Prof. I appreciate this, and I know that participants may have to some questions when we come to that, but we will need to now get to our second conversation, and that will be by Dr. Tewalade Adeniyi. Dr. Adeniyi, you have the floor now.
Okay, thank you very much, Mr. Innocent. I'll just share my screen now. Okay, it's picking up just in a few seconds. Oh, they said, so the host has disabled participant sharing screen. Is this something you want to enable?
Have you shared? You can share now.
Okay. Okay, so good afternoon, everyone. Thank you very much for that first lecture from Prof. So my own direction now will be to look at the approaches to reduce emissions in road and building construction. Normally, I'd have gone through an introduction, but these are some of the things that Prof has covered, so I don't want to be repetitive. But on a global scale, we've noted that 39% of all carbon emissions in the world come from, the building and construction sector, and the operational part, that is the cars moving on the road or the building running, accounts for 28%. So what we are worried about now is, for now in the construction sector, is this 11%, whereby the construction phase comes into play, and that involves the material usage all the way to the point of at least to start operations. Generally, the biggest GHG emission source in the construction sector is energy. And just as Prof has said, a lot of construction processes still use a lot of non-renewable energy, whether it is natural gas, oil, coal, and I mean, sometimes even as worse as petrol or diesel, which even leave impacts on the road sometimes. But that's where we are at this stage. And it's also very good for us to note the GHG generators. So what are the generators in this entire construction process? We have the materials, which some will say is the supply chain, but nonetheless, they're still the materials. Mr. Innocent had given us giving us the carbon emission equivalent for each of those products earlier, cement, bricks, and all of the likes. Then we have the equipment, which is also a big factor, the equipment usage, transportation of these materials to site, from site,
And then land use change, very, very key. Just like you said earlier about forests being destroyed in Cross River, it's happening everywhere. When these things are done, there's no provision to actually reabsorb this carbon, maybe by planting trees across or making gardens and other smaller efforts. But like I said, my focus will be on the approaches. I won't want to go into details of what Prof has talked about, and the approaches are very, very practical, and some of them are actually being used. The first one is in the materials. As we know, these materials are heavy in terms of carbon GHG emissions, whether it's the concrete, steel, even wood sometimes can be heavy, because wood most likely is going to lead to deforestation if you don't plant back.
Yeah.
So, but nonetheless, we've had issues where we've had situations where a lot of construction have been done reusing and recycling some of these materials, concrete, steel. I'm sure Prof will be able to give more insights on when we calculate BOQs in construction sites, that is bill of quantities, where some contractors come with some ridiculous quantities to be used in construction, and where an environmental engineer or an engineer that knows about sustainability comes in and starts cutting everything down to say, you don't need all of this if you reuse and you recycle some of these materials. Also, we've seen the use of warm or half-warm asphalt. We know that in Nigeria, we like to use the asphalt hot. Hot means more emissions, hot means more energy, but if they're used warm at a lower cooling temperature, they perform the same function. Also use of fly ash in concrete. This is mainly used in countries where they have a lot of coal residues. I know that Dangote is trying to do that, especially because the Opajana plant is being run on coal. And so it's something that you can introduce fly ash into concrete being used for road construction, and even sometimes for buildings, because fly ash has also been known to be a very good sticking agent. Then we look at it. Then another approach here is also innovative materials and alternatives. So over time, of course, a lot of research has been done, and some of these things have been translated to the field. Unfortunately, not in Nigeria, as we know. Environmentally friendly concrete, that is minimizing the use of Portland cement, which is most used all over the world, which we are very happy to use. We know why we're happy to use it in Nigeria is because most of our roads are being plied by trucks that normally shouldn't be plying the roads. They are very, very heavy trucks carrying materials that should be gone by rail. So that first innovative approach might take some time in Nigeria because of the strength and the tensile strength of some of our trucks. Microalgae, this is something that scientists have looked into to create an alternative to asphalt. It's being used to actually increase viscosity. That's been done. New surface material as well. So some organic resins are being used now. I've seen people use congealed plastics. People use congealed styrofoams. Yes, this has not been done for large scale roads where you have big heavy trucks flying. We've seen it on estates, in residential buildings, where some of these things are being used for the road or for the pathway or for the gardens in those buildings. And then pozzolans. If for people that have gone deep down into cement manufacturing, we know that this is the first place we started looking at limestone, pozzolans, they're volcanic rocks. And in areas where they have a large volume of that, they begin to reconsider them because they have lower carbon footprint compared to cement. Still on the materials, we should also note that we mentioned, Prof earlier mentioned replacement of wood and steel. I wouldn't want some people to get confused that are we going to be using bamboo for Third Mainland Bridge? No, it's not. It's not that kind of replacement. But over time, research has shown that safety barriers is actually responsible for 25% of GHG emissions in road projects. And this is not without doubt very evident in Nigeria. Now, I've shown two pictures there. And one picture shows a kind of highway in some sort of a developed country where bamboo is actually being used as the safety barrier. And then we have in Nigeria here where ordinary to close Third Mainland Bridge, just to say Third Mainland Bridge is closed, we couldn't even use bamboo or plastic material. We had to put an entire concrete just to show that the road is closed. I mean, somebody colliding with that concrete in the safety is a safety hazard on its own. The safety barrier that, I mean, you can't have bamboos or you can't even have reinforced plastics. It has to be concrete. Everything just has to be so hard and difficult, and all of this leads to more emissions. So location of safety barrier, redesigning some roads whereby you have wood barriers. Yes, we won't have wood barriers on Third Mainland Bridge because of the water, but I've seen areas of Third Mainland Bridge. I don't know if some people can know this or remember this. I couldn't get the picture. But there are some areas whereby maybe you're about to climb the bridge around the Adekunle or Yaba axis. These areas are very close to residentials. They are very close to houses beside, and then you still have concrete reinforcing it. I mean, to me, I don't think that's really, I mean, that's a waste of concrete. But this was done way back. So it's just a lesson that going forward, road design should actually looking at areas where they can reduce some of the usage of these high emitting materials. Now let's go to equipment. Equipment is very key in construction, whether it is road or building. And we tend to use, well, luckily for us, Nigeria is not yet in that picture, but we tend to use heavy equipment instead of labor-intensive techniques. So naturally, research has shown that using that, a form of light equipment with labor actually reduces your emissions, which is true. I mean, people will emit less than the equipment. I've also shown two pictures there where they are laying asphalt, another one is controlling cement, and where one part is using labor to actually make sure that the asphalt is straight. Another company is actually doing everything using asphalt layer, also making sure everything is straight. So where we have an equipment that can actually lay the asphalt and straighten it, but to avoid it spreading to the roads, another company has decided to use labor, while one company is using a bigger equipment that can prevent that. So again, research has shown that if it's for the same purpose, which is to make it straight, human error is not that significant. So why don't you use more labor-intensive techniques to reduce your emissions? And generally, equipment selection, fuel selection. Now we have equipment running on natural gas, which is less polluting, reducing idling. I do not know if most of the people on this call are aware of what is going on in Lagos with the Oshodi-Apapa Expressway being done. This is a route I pass almost every day. And sometimes on the route, I just take pictures of equipment idling. I mean, they've not finished laying the cement, and the guy that wants to straighten the cement is already running the device. Maybe it's to keep it warm, I don't know. But we have that high level of idling, and sometimes this thing can be neglected. So contractors just feel it's nothing. It's not a big deal. I mean, how many minutes is this going to run? Not knowing that 10 or 20 minutes has actually contributed a lot to global warming on the larger scale. Equipment maintenance is key. We've seen situations where equipment actually break down on site, and then properly sized equipment. So this properly sized equipment will also take us into transportation. Now, this is another key part where emissions skyrocket in construction projects, especially even in building construction. So again, we now have natural gas power trucks, so we don't have to be relying on petrol and diesel. The size of trucks matters a lot. I've seen sites where we just see tiny trucks supplying sand, and it's or granite. And the more trucks you have, the more emissions. Get larger trucks that are going to emit less, and make your transportation more efficient. But we see, a couple of smaller trucks just coming in and out, and it's more emissions. It's also more gridlock in terms of traffic, and then improving driving habits, less idle time, more night transport. Night transport means that you get to see less traffic during the busy period, and you reduce your emissions. And also, I don't feel some of these things are also very, very important in reducing cost in construction. Sometimes we come up with these reduction approaches and contractors think it's going to increase cost. But by the time you do the cost benefit analysis, you find that it's actually cheaper. It's cheaper, you use less diesel, you use less petrol for your truck supplying the sand. All it takes is better planning and design. You don't have to make everything rush. They're always doing things in a rush, so they want all the trucks to come on the same day. But when you have a plan of a 3 or 5 months plan, where you know where your raw materials are going to come, then all of this can be put into perspective. For a country like Nigeria, yes, we'll try to shift long distance transport into waterways or train. For a developed country. In our country, it might not be possible, so that your supplies don't end up on the wrong side of Apapa traffic, even when you are going through the waterways, and then optimizing on-site transport. But I just wanted to talk about our waterways also. I've seen transportations of heavy beams for bridges being transported by road, and I just wonder. I mean, these are things that are going to cause damage to the road themselves. Very, very heavy beams that we could have actually done using a lower, not a deep ferry, but a ferry that could dock in a kind of shallow port. And then land use assessment. Just like we've said, land use change is critical in any construction, whether it is residential or building. Land use, this is the part where we do the environmental impact assessment. I mean, to check the land use. And a lot of constructions don't put this into perspective. They just feel the road is more important than the vegetation, or the road is more important than the households. And once we begin to think like that, then we begin to run a capitalist economy and we forget about sustainability. So land use is also very key in reduction approaches. But very quickly, I wanted to run us through rating systems. And why did I want to do this? Prof mentioned earlier that there are about 6 or 7 buildings certified. And I wanted to reiterate this. In 2014, IFC came together with EDGE, that's Excellence in Design for Greater Efficiencies, and they did the EDGE building certification. And for now, only 5 buildings in Nigeria have that certification. The Alpha 1 building in Atlantic City is a commercial building for offices. The Green Age Student Housing in University of Abuja is still under construction. The same thing with the Blue Water Lagos Homes. This is actually being done by ACA, African Capital Alliance, with Elalan. The Cornerstone Towers are residential. And then the Peridot Parkland Estate in Abuja, also residential. Cornerstone Towers are commercial. So these are 5 buildings that have been certified by EDGE. Now, unfortunately, I don't think there's any building certification or green building certification locally. So for now, all of us will be using the IFC EDGE. But the EDGE has its own limitations. And the limitations is that EDGE doesn't focus entirely on construction. EDGE focuses a lot on operations. So after the building has been constructed, but nonetheless, EDGE also takes into account the raw materials used in construction. So it takes into account material usage. But EDGE, for instance, will not calculate transportation or the transportation of the materials or the land use. No, EDGE wouldn't do that. EDGE will focus on the operation. So after you build the building, what's going to be the emission, energy and water reduction, and also raw materials, energy and water reduction that were used in the construction phase. But nonetheless, it's a fantastic starting point to begin to rate buildings. And for roads, we have several. Unfortunately, none of them have been localized. We have STEED, we have Envision. These are not things where I don't want to go into because most of them are foreign, but these are things that companies that are ready to go into green roads can start looking at because they are universal basic standards. STEED, for instance, is the most applied. It's actually sustainable transportation, environmental engineering and design. Very, very good checklist, very robust to make sure that your design actually aligns with sustainability. So you can also try to reduce emissions from that. So it's very important that we look at these rating systems because if we're going to be looking at reducing emissions, we need to have standards. And these are some of the standards that currently exist. Hopefully there'll be more. Maybe some of the other speakers will be able to shed more light on more, but these are some that are quite easy to relate with. So thank you very much for the attention. I hope I've been able to cover some of these approaches and we'll be willing to take questions after. Thank you.
Okay, thank you. Thank you. That was very enriching. We cannot go on to rehash what you already have given here, but it's very loud with respect to the approaches, especially with respect to materials recycling, adoption of innovative materials, and the use of alternatives, to enable our construction activities, particularly given that we adopted some practices, before now, and which we need to change. But now we're in a crossroads between not having the appropriate policy to excite or encourage this to happen, and then having some, foresighted, investors going ahead to lead the way. So it's very, very, and you've given us also some of those innovative alternatives, very important. The environment-friendly concrete, and then they have microalgae, and then you have this new solid material and the pozzolans. Very, very revealing. And I think that what has happened from this conversation is that going forward, we've got to push it in ways that ensure that stakeholders, actors in this industry, go to any land to receive knowledge, to get information. At whatever level they can reduce emission. Nobody is saying do it 100%, but if you do 10%, for instance, learning to have a machinery to go off generating emission into the environment when it's not working, when it's just idling. Okay, it's a knowledge stuff that we need to have practitioners or actors to imbibe, and it starts with companies having the right practical environmental policy, which they put in place even when they are in the field. It's very, very, and then you mentioned things very close to us, the safety barriers. When you go to some places where you have wood bridges or wood safety barriers to cross streams, normally the first thing you think about is that this is a rural area, okay? But you are not thinking that, oh, this has been done in a way to help the environment, and it can actually be done better. Instead of doing concrete and iron, you simply, use wood, do hardwood, and do some, even though that one is also reducing, in terms of land use, reducing some forest stock. But we have to know between this and that, which one is saving emissions for us. You've also mentioned, the issues of equipment. Again, the labor versus equipment intensity trade-off. Okay, can we bring in lighter equipment and use more labor? Now, for instance, I could just give an example from the news, recent news. Ministry of Sports wants 81 million naira to cut grass at the stadium. Could they employ young people there to just go cut it rather than allowing equipment machinery to go into the stadium to destroy the soil? So these are things that we need to get into our knowledge base to help us to do better. So we can reduce transportation, like a whole lot of things. This is really a faculty of knowledge that we are getting from this conversation, and I'm very, very glad. I cannot say all this. Well, coming to ratings also. Rating is very important, and many people, I can assure you, do not know this is happening. Okay, they don't know the rating of green buildings, and if we begin to excite activity or activism in this way, you might find that we say 10% energy reduction or 10% or whatever reduction, emission reduction. Okay, we can give you a certificate for that purpose, and that is what the carbon exchange, the eco-carbon exchange, want to start to do. If construction is going to happen, and we're able to determine and quantify from the baseline scenario what reduction has happened, we will create credit for that, or engage, credit creation for that purpose, and then we create certification for that. Certificate, at least, first of all, certificate for that, to show that this is how far you have done. This is what you should have done if you had not engaged in reducing emission. And then we can also, from there, create more knowledge in policy cycles so that some of these things can begin to grow. And so we have the expertise on ground. We have expertise in-house. Everywhere, we have expertise here and there. Prof. Adeni, Togewa. So what we need is to come out to this space, come out to the open space so that people will hear Sorosoke, so people can now, hear what is going on, the amount of knowledge we have. I want to thank you again for this, and I want to believe that going from here, we need to really push this into the space. We need to push it. We need to use all the media that is available to push it, whether it is television, radio, newspaper. We need to. The professional associations need to come out. They need to begin to push it. It's doable. It's doable. I thank you again for this. I'm sure that some of those who are joined us may have some questions. When it's time to questions, I also have one for you. So we go now to our top presenter, Dr. Gewa. You have the floor now. Dr. Giwa, yes.
Thank you, Innocent. I'm just going to share my screen with you now. So if you enable me to do that.
Yes, surely. Okay, you can do that now. Are you able? You have to unmute.
All right, yeah.
Very good.
So thank you. I guess you can see my screen now.
Yeah, yes.
Just 1 second, please. All right. So thank you very much. A lot has been said from the past two, presenters, and I think I would just sort of piggyback on everything that's been discussed. There's a lot of information they've provided on reducing carbon emissions, in the built environment. That's a combination of the building industry and, of course, roads. What I'll share with you today is more of our experience, having done this, as I said. The Foundation for Partnership Initiatives in the Niger Delta are invested in what we count as a green building, a sustainable building, a low carbon building in the heart of the Niger Delta. So just what you're seeing right now is just a quick snapshot of the destination. There's an environmental imperative for the building construction sector, where we need to get to in terms of the work that should be done towards reducing emissions. There are different commitments. Nigeria is one of the, Nigeria happens to be signatory to many of the international conventions, towards reducing carbon globally. Global construction industry, particularly the building industry, contributes immensely. It's an opportunity for a sector like Nigeria, to contribute to as part of their own NDCs. That's the nationally determined contribution towards reducing emissions. The other sectors too, when we talk about buildings, we don't talk about the residential, the industrial, the commercial sector. Matter of fact is that many things happen within the building. So you really can't even isolate and say, oh, well, it's just the building. When you think about the industrial sector too, the opportunities for the industries to reduce emissions lies in their buildings, one way or the other. They have to retrofit buildings. The heavy engineering companies have to, organizations have to think about how to retrofit buildings and get them, as a way to contribute to their own environmental stewardship. So now, how do we go about it? Building construction related emissions are largely, as Dr. Tiwa said, embodied energy, which constitutes about 11%, and the operative energy, which is about 28%. In combination, that's about 39% for the whole sector. Embodied energy means the primary energy that goes into the manufacture manufacture, installation, transportation, use and disposal of materials. All the component materials that goes into a building assembly. That's the bricks, the mortar, the joinery, the floors, the timber materials, the paint, and the like, the roof materials, the tiles, ceramic tiles, and the like, the materials that go into a building assembly. And so the embodied energy, for example, using a brick is, if you take a unit of a brick, there's actually something you can qualify as, for that one single unit or a square meter of such a building, of a building wall, you can say, okay, well, it constitutes so number of emissions. Yeah, that's contributed to a number of emissions. So that's embodied energy. And that's an opportunity, you know, because we can actually reduce that. We have a lot of control in a place like Nigeria to reduce that. Same thing, operative energy is, you know, in life, when a building goes live, you know, how do you reduce, you know, some of these, the operation, you know, the energy that goes into the running of the building over its lifetime, you know, what's considered its operational life, you know. So we combined these as PIND, you know, while we were trying to look, we had the aspirations to, you know, to demonstrate what a green building, a sustainable building would look like. So we had those aspirations and we set about the task. We defined what we wanted to achieve. So this our case study in this case is the ATED Center. And ATED, for those who don't know, is the Appropriate Technology Enabled Development. It was an intervention, it was a project under which PIND ran over the last 5 years. And we wanted the center for, you know, as a hub for those activities. So we wanted to build, we wanted a low carbon building essentially. This building was constructed in Warri, in Delta State. It was built in 2015. It was built to the Passive House standards. And, you know, many of the, Dr. Tiwa particularly said something about different, you know, sort of standards for construction, ratings and the like. Passive House standards is emerged from Austria, you know, from the Passive House Institute. It's very common around the German-speaking parts of the world and some parts of Europe as well and America. It's a way to sort of save energy, you know. The whole practice and the whole idea of building using Passive House is using very passive rather than active methods, you know, passive solar design, using, you know, using the sun as a way to, you know, taking the energy from the sun and using it to the benefit of the building design. Our building, you know, compared to normal, if we were to go through the conventional building methods, you know, as a new build, we were able to save 75% in terms of the energy that would have been utilized in that building. We took an opportunity around the mass of the building. I mean, the walls, the, you know, the envelope, the mass of the building is actually, is one of the components that has the highest concentration, you know, in terms of mass. For traditional buildings, you'll be using things like hollow concrete, you know, sandcrete blocks, which constitutes, which has a lot of concrete in it. But in this case, we used stabilized compressed earth bricks, double glazed windows, you know, there's water efficiency, the whole combination of everything we did to achieve that building. That's what you've seen it. So this building, compared, you know, to business as usual, to a business as usual scenario, has reduced, has a massive reduction in its environmental or rather carbon footprint. Now, before we set about doing this, what were the things that we tried to identify? You know, we wanted to identify in a country like this, we can't just use a template. There's the general, you know, category of things that we, the usual suspects, you know. However, in a place like Nigeria, you can't use, since we don't have the standards, we have to adopt what is most reasonable. So we expect a lot of, you know, understanding of the local context. It has to be contextual to what we practice in the country. So some of the key things that we know that we were, the environmental categories where we're prioritizing is climate change, fossil fuel depletion, ecological emissions, you know, which of course, you know, leads some way to some degradation of the environment. Water is a very, very major resource. We think about water scarcity, the water stress index for most localities in the country. Resource depletion, that's your trees and, you know, clearing of site in itself, you know, has a major bearing on that's when the footprint of a building starts to count, when you start felling trees for, you know, to site your building. Waste disposal, it's a major part, either construction waste disposals, or even waste disposal during the life of the building. So these are some of the very, very key areas that we've looked at, and we felt we're able to make some. We can move the needle if we look at these impact categories. So how did we go about it? Our approach was largely what you call a cradle to grave pathway. That's a whole life cycle. We look at the whole building, looking at the whole life cycle of the building, right from the time that brick comes out from the factory, to the time that it's shipped to the front of the site, which we call the cradle to from cradle to the gate, to the site, and of course, to the end of its life. So you can literally track every unit of material used in that construction in such a way that you can think about its replacement. For some materials, they will probably have a 25-year lifespan. Some materials we need replacement 10, 15 years down the line. So we do a very thorough kind of analysis, at that initial stage to look at what these impact per material and specification would be. This is another opportunity. So while we were developing this, it's a framework essentially, but then it also looks at, if you look at the left part of that screen, you can see that it's for new buildings. But of course, the moment your new building spends a couple of years, it becomes an existing building. And Dr. Tiwa was making reference to the Edge, the IFC Edge tool, largely catering for some, constructed buildings. So if you have those kind of constructed buildings, what are the things that you need to still keep your, to keep your eyes on, so that you don't lose all the benefits that happens at the initial stage while trying to do all that gains with the embodied carbon. So for us, we looked at three key things. We looked at the design, we looked at the material, and we looked at the technology that goes that supports all this whole building assembly together. So what you have on this slide is just a quick sort of overview of what our design strategies were. We had the sort of it was a passive design. So, our roof, our whole shell, and the whole structure is designed such a way as to take advantage of environmental, lots of the environmental factors, the wind, the sun path, and things like that, So our roof, for example, in this case, has a roof vent. We call it a breathing roof. It's able to absorb, and you can see some of that pictures on the right side, where some of the heat that comes in through the heat gain from the top of the roof is able to be, we have a sort of cooling system whereby that heat doesn't get down into the building. So these are some of the this is design, and once you put it in place, it stays for the life of the building. So it's a key decision that needs to be gotten right, the design of the building. And next is materials, like I said earlier, one of the key materials that we utilized was the compressed earth bricks. Compressed earth bricks has less CO2 emission because it has very little cement material in it. We all know that cement is heavy in terms of its emission. It has a heavy footprint in terms of emissions. So the less cement you use, then the more you're contributing towards, reduction of emission, or rather the footprint. So compressed earth bricks is largely a combination of laterite and Portland cement as a stabilizer, but then at a very reduced amount of use of Portland cement. It's able to perform the same, and in fact gives us better properties and better qualities than what we desire, what the industry provides. What you would find on the normal market, which is the normal sandcrete blocks. And of course, it's also locally sourced. We have a huge deposit of laterite around parts of the Niger Delta. If you're approaching, northern, what would be around the Benin axis, there's a lot of red earth. We have red earth in parts of Ondo State, And all these things form, they're materials that are there under supervised kind of mining. These materials can be harnessed locally and cutting largely the sort of transportation emissions, and that adds to the embodied energy of most materials. And next is the technology. Technology is another opportunity. When you combine all this, design, material, technology, you're looking at optimizing, the sort of performance you will get from your building. In our own case, technology, we went, above and beyond. We utilized double glazed windows, which of course it's able to help preserve the heat transmission between, the internal and the external part of the building, while at the same time we can see traditional windows that we find in the construction, in the builders market, are normally single glazed windows, and they have very low thermal properties. That means while you want to look outside, we start considering reducing the window area. But then most people want to have a white surface. You want to see outside, especially if you're in an office where you need a lot of task lighting and natural lighting. You want as much daylight heating coming into the building. However, you need to consider, the heat loss that comes from your air conditioning and standard. You will be powering the air conditioning constantly just to keep, just to have that sort of temperature that you want. So the double glazed window is an important technology that came in there. Also, we have a air handling unit, which is a major technology that supports our passive houses. It sort of maintains the indoor climate, and it works. It's a smart system. All the technologies that we also explore this in terms of waste management. We have we have a composting toilet. We have a biodigester, which actually just treats the solid waste from the building. So there's no, over the life of this building, there will be no requirement for, sewage, evacuation of sewage and such. The material that comes out from there is actually some level of composting when diluted. And at the same time, we get biogas from that. So these are sort of all these, different technologies that you can combine at a small level, or going the whole length to bring all this together to have that sort of reduced emissions for that building. So that's what we did at Paint. Some of the guidelines, we've heard about the different standards, not having a standard in this country. But why we don't have a standard in this country, at the same time, many organizations, especially when international organizations who have a requirement to, for environmental stewardship, and they've already signed up to different charters to always demonstrate, sustainability and environmental responsiveness. So they tend to use other standards that we can classify as global. The ISO provides us this platform. So there's some of those guidelines that we can find there, which cuts across any industry. And for construction, you find the roadmap to zero emissions, which is a major body of research that came out from Architecture 2030. Then we have the British standards, sustainability of construction works, environmental product declarations. This is a supporting site for, this is a supporting document for the specification industry. Specification is the backbone of the construction, Then there's also the Green Guide to Specification. Now, there's a host of others. It's just you need to just choose. There's the need to have an understanding of the sector, of what you can combine, and I think with that we can begin to now sort of have those different organizations practicing, adopting these different building methods, and then we have the critical mass to actually influence a major change within the Nigerian building sector. And that should be all. I'll take questions after this.
Yes, 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 yes. And thank you very much, Dr. Giwa. That has been very, very exciting to, to see what you have also done locally here in practice to let us know how buildings can be totally green. Of course, while I'm going to start the questions, I will also want participants. People have been coming and some are coming and going. But if those who have been on with us since the beginning, they have questions for our panelists. We have Professor Tebolu and then Dr. Denny and Dr. Giwa. Please, you prepare your questions. You can raise your hands. But looking back at what Dr. Giwa just shared with us, you see that's a marvelous piece of work that Payne has actually done. Some of the aspects that really is intriguing is the fact that you have to modify the wall materials using the earth and cement mixture. I know that we have mud buildings. In the rural areas we call them earth houses or mud. But again, this is what you're actually replicating. This is what you are pushing, even when you have some proportion of cement. And I have also read somewhere that cement at some point begin to absorb carbon dioxide from the atmosphere. So it may now be, what's the proportion of cement, proportion of the earth material that comes into what we are using to build our houses. So yeah, it's an interesting and exciting work that Payne has done there. While we'll be expecting our participants to raise questions, I may just want to start with you. There's a whole lot of things you've done. 75% energy savings on operational energy savings because you have used double glazed windows, and then you have used stabilized compressed earth brick mass. On the whole, what is the total emission savings that this building has really created, given that the ordinary scenario, the business as usual scenario would have been, hey, everywhere is full of emissions from wall, from foundation to buildings and all that. Were you able to estimate what emission savings that has happened all around because of this structure?
Yeah, thanks, Innocent, for that question. And that's not the first time I'm hearing that question. It's very common for people to ask us, are we tracking? So yes, we're tracking on two sides. The operational energy, which is compared to another building which we have on site, using almost the same floor area, the same amount of load in terms of that building. We're tracking that. We have data. We're collecting data, logging the data for a while now. But generally, there's so we know in terms of the general, if we sit at the desk and run an analysis, at the analysis level, we know that we can do as much as 75%, but that's we need that to be validated, and that's where all these sort of tools come in. We need some level of validation. There are different standards and different tools. By our own self tracking, we know that we've done as much as that 75% in terms of operative energy use. We know that by normal standards in terms of the construction energy, we're able to reduce as much as between 30 to 40% of what will ordinarily go into the construction, at the construction phase. But then you don't self-declare, that's another thing. You need third-party verification. For some third-party verifier to come and actually, give us a declaration. On the other hand, just to add to that, just to add a bit more to that question is that There's the question of baseline as well, you know, which is, for me, it's a very, very strong thing. You have to benchmark against performance. So now, how are we benchmarking? We're benchmarking against that building that we have on site. If you really want to ascertain that we've done very well, you can't use that building. What we're doing is that we're doing it's a relative, you know, what we call the business as usual scenario, because we will build that way. And that is very satisfactory for us, understanding that we've made an attempt and made an effort. But then the industry at large needs to look at the types of buildings, you know, all the types of buildings, the standards, the research institutes need to come together. There has to be a consensus, which is backed by scientific data, that this is what the standard should be for a Nigeria environment, to say, okay, we're going to benchmark against this particular baseline, either for the for all types of buildings or maybe specific types of buildings, be it residential or commercial. I hope that answers your.
Yeah, no, that's very good. You know, it's good to hear. Yeah, and I want to say that Co-Carbon Exchange is available to you know, kick off a process of validation of your emission reduction in that building. And I think it's also going to serve a major, you know, landmark promotion for similar stuff, similar projects. And of course, it's something that by now should have been also on national canvas with respect to creating standards for buildings. You are doing 75%. Based on, you know, what you are benchmarking next door, but we can do 10%. I know if we can quantify that there's a 10%, there is a 20%, there is a 30%. Just like you said, we can now have standards, and you know, emission or carbon quantifying agencies, you know, can create credits along that line. I will just go to Dr. Giwa, but I will also ask. Because you have not validated emission reduction, emission savings by the ATED building, it tells me you have not earned any credit from that structure. Have you? When I mean carbon credit.
No, we haven't. No, we haven't earned any carbon credit on the structure.
No, that's a big loss.
So we probably should be talking to the likes of EcoCarbon.
That's right. That's right. That's right. When I started this conversation some years back, a presentation by a bank official said that after they have, you know, enabled the LAMATA, the Lagos State Transport Bus Pool, to take operation, they just found out that they didn't create emission reduction, you know, income that could have come from that, and it was a regret for the state. And I think they have changed their mind. They're doing things better now. You need to earn some incomes from emission reduction. 75% is not 7.5%. All right. So we'll talk about that after this conversation. And I'll go to Dr. Adeniyi. Dr. Adeniyi, you've given us, and please, if we have anyone who wants to provide a question, we would like to read that. Okay, maybe before I go to Dr. Adeniyi, let me just read what is here. Somebody says, Dr. Giwa, thank you for that wonderful presentation. Is the emission quantification really necessary in Nigeria, necessary in the Nigeria business space? Is there a possibility of having green building, and what can someone do to change his construction or structure to green? The third one is there any incentives attached to such building in terms of grant that PIN provides? Let's look at that one. That one mentioned PIN. And I would like also Dr. Adeniyi to look at the one that says Nigerian business place. Is there any incentive to do this? Should we really be doing it? Should we be encouraging it, giving our business space? And then what can someone really restructure or retrofit. I'm sure that this came along during the conversation. But Dr. Giwa, is there anything you do for those who want to be involved in that? You said, is there any grant that PIN? Does PIN grant anything to encourage others to follow your pathway?
So thanks for that question. I can see from, okay, thanks for that question. Yes, PIN provides some form of incentive, but that incentive comes in the way of training. You know, the knowledge needs to be there. As a way to get us our own efforts within the sector, we're able to introduce two pathways, intervention along two pathways. And those pathways were, you know, looking at the general build, the professionals, you know, as the people who will be putting these buildings into practice. I mean, to build in this country, you need to have professionals, you know, they need to take these buildings need to be vetted, and, you know, if they don't know, the finest buildings don't necessarily mean anything. They may have in many cases, they have the worst environmental credentials. So if they are trained, then they understand what they need to do, you know, to reduce their, you know, the footprint of their construction. On the other hand, we look at the schools as well. You know, that's the training bed for the future workforce. You know, if you're thinking about a 5-year strategy, you need to think of the workforce in 5 years. So we had a sort of intervention that looks at we work regionally in the Niger Delta. So we looked at the tertiary educational institutions in the Niger Delta with built environment faculties, and worked with the whole, you know, training. We had to provide some form of training for the identified, you know, key, you know, stakeholders in those departments, so that they can cascade the knowledge. So this was like a training of trainers. They can cascade the knowledge. Students can, when the demand starts to come, students can begin to, you know, find firms that are actually practicing green building firms. Green building firms can easily recruit students. So it's in that middle, that's our sort of intervention. However, another thing is that our building, our resource here in Warri is actually a major resource that we provide as a resource for anybody who's interested in green building activities. You know, either they want to research, either they want to come in there and just, we have a library, you know, and just sort of the like, people who want to experience a green building firsthand. If they want to innovate around it, I mean, we're welcome to know that. We like things to come off our adoption.
Okay, thank you very much. So the ATED building is available for people to come and learn how it's done and adopt and to do. That's good to hear. And maybe we also need to do more publicity to get traffic into that territory. Thank you very much. Now, Dr. Deni, you may want to respond to retrofitting or redesigning or restructuring a Goslar, you know, a building that is already, or a road that is already throwing a lot of emission into the atmosphere. That's a question by the same person. Can you intervene?
Yeah, so I always say that sometimes it's never too late to change direction. But you know, the question is wide, is a bit ambiguous, because we never can tell at what stage of construction do you want to change your design to green. But I think the first step and the most important step is like what Dr. Teslim has said. There must have been, I mean, you must at least start measuring something before you even say you're going green. So before you talk about, so you want to go green, you're dreaming about green, what exactly are you emitting? Because you remember that if you want to go green, you must be able to get zero emissions, zero nets. So you must make sure that whatever you're emitting, at least you've been able to cover it up. So it's not just reducing. A green building is not going to say I'm reducing emissions. It has to be positive or at least zero net. So you have to be able to quantify first. And then when you have quantified, you can now look for places where you can actually reduce emissions, or approaches where you can reduce emissions. But the first thing is to quantify. And this in a way aligns with the first question where you now asked, is it really necessary in the Nigerian business space? Now, this is the question that most people always ask. But the first thing I always tell people is that before we even go into environment and the good things about knowing what you're emitting, what we have found out over time is that it is actually cheaper. So it's a cost-saving measure. So if you don't know your emissions, sometimes you don't know what to cut and what to throw off. It's like when you're doing your finance, you want to know where you have leakages in payments of salaries, where you have leakages in workers. If you are paying 1,000 people on the site and you find out only 500 are required, you cut it off. That's exactly what emissions is like. So you're seeing that you're emitting a lot, you cut it off. So sometimes you see that you're cutting off some unnecessary equipment, cutting off some materials that you need to buy. So the first thought you must have when you are looking at this, sometimes, this is what I always tell business leaders, because they find environment kind of a cost center. The first thing I tell them is that you have to think of it as an approach to reduce your cost. Once you think of it that way, then you don't forget about it being in the Nigerian business space. Once you find a way to reduce your cost, like every business, you reduce your cost. So in the Nigerian business space, it now gets better because it's an emerging economy. It's an emerging market. We have carbon markets starting. You can always speak with Eco Carbon. They'll tell you all about it, how you can generate credits from doing this, from quantifying and then looking for how to reduce. You have, so because an emerging market, the carbon market is quite, is going to be robust anytime soon. And also you get competitive advantage and investor confidence. Depending on what you're doing, is it going to be a road or is it going to be a building? If it's a commercial building, in fact, the investor confidence is almost tripled. In 2020 alone, if I go off tangent a bit and talk about the number of investments that came into ESG funds, even regardless of COVID-19, was into trillions of dollars. And these are investments into green buildings, sustainable transportation, and I can go on and on globally. So it gives you that edge to say, I can declare what I have, even if it has not been certified. This is what I'm doing. This is my mission. This is what I plan to do. It gives you that hope of actually getting better investments. So I hope I've been able to answer the two questions. Where the first on how you can go green, and the second one is actually is it necessary in the Nigerian business space?
Yeah, very important response you made there. I love the intervention. And it's what I'm going to be asking Dr. Giwa later to let us know the cost differential between what in the short, medium, and long term between the buildings that they have been generating data with respect to ATED. But also for me to ask Prof. Prof, are you there? Okay, Prof, unmute yourself, but this is going to you before I come back to Dr. Giwa. At this stage, to what extent are we, hello, Prof? To what extent are we, to what extent are we mainstream this knowledge among, in our faculties, especially in engineering, in the building, the estate surveys, in the universities and all the training institutions? Because you see, what Dr. Giwa just talked about, the training facilities or opportunities they provide to build capacity, both individually and as a business, to begin to mainstream low carbon practices in businesses, I mean in buildings or in what is it? Are we doing that for students who are going to be hired by the companies when they come out? Or what is the challenge?
That's a very good question. Are you with me?
Yes, I'm here.
I said that's a very good question. The first thing that most university curriculum is running obsolete, I must say. And this training depends on individual lecturer. If a lecturer has interest in sustainability or on environmental sustainability, he may introduce it to students on his own. But I think there's a need to create awareness of the importance of this particular topic to different environment departments or faculty, so that they will now include in their curriculum development. I know that NUC is about updating curriculum of universities, and lucky enough, I'm to represent my department in that committee. So, and I've been trying to include it in my own teaching, but that's not universal. is personal to me. So I want you to now to find a way of spreading that message to every built environment, architecture, building department, estate management, quantity survey, and so on and so forth. So it is, we have to move with time. The curriculum we are running is for the past. We have to bring curriculum that is for the future, so that the people we are training in universities will come out to meet the needs of the society. Not when you come out, they start training you again as if you haven't gone to school. So I accept that there's a really shortfall in the training of.
Okay. Okay. Thank you. Thank you very much. Are you done? Hello? Hello, Bob? Okay. All right. So that's fine. I will also want to now ask Dr. Gewa, when you check the cost differential between, flowing from what Dr. Denny just said, that you need to see it as a cost reducing, investment that you are making. Don't look at it as okay, you're increasing costs to cut emission. Apart from the fact that when you when you evade or avoid the emission in the construction that you are doing, you can still offload down reduction, on the carbon markets and get your income again. But from your experience, what happened between a third and the other buildings you are using to benchmark in terms of cost? Yeah.
Yeah, all right, thank you. So I would like to speak more about what the rule of thumb is, for buildings that low carbon buildings, and rather than ATED specifically, I'll still speak about the ATED example. And the rule of thumb suggests anything between 25% to about 40% higher costs for a normal building, for a low carbon building. If you use the, sort of everyday kind of, the common improvement measures and the design measures and the like. However, for ATED, in the ATED building, what we did was an absolute demonstration building. So we went above and beyond. If you look at greening, if you look at many of the ratings and other parameters for measuring, at times you find deep green measures. You find green measures, you find deep green measures. And that's why they tend to have different rating systems as well. Platinum, gold, and, different standards. So what we did is we brought about all the suite of, technology, materials, and design principles. We brought everything together. So where the ATED building sits at the top. So cost-wise, we weren't looking at the cost at that time. We were more interested in demonstrating, the possibilities within the country, within the region, in a place like Warri. And, so now this is an interesting part for everybody who's interested as a researcher, as different, all the guys we work with and guys in the academia. It is, I come from a research background, so I understand that I can isolate, using parametric design, I can isolate these buildings as an architect, as a builder, to say, okay, well, I'm going to build a 2-bedroom flat based on this sort of design principles and some of the materials. And it's easy, I can do the costing at that level. So what we normally give people is a sort of very level playing field to, choose the sort of things they want to adopt. But then we still tell them about the rule of thumb that traditionally these buildings with, some level of adoption of the bricks and other, basic material, other things, you'll come between 25 to about 40% higher cost than normal buildings. Another important part of that knowledge for them is that this is always around CapEx, what you classify as CapEx in the building industry. We need to start looking at buildings not because of its initial costs, but of course the whole life cycle. You will never get the benefits of emissions, reducing emissions in buildings just at the beginning phase. It has to be in terms of thinking about the whole, the whole 9 yards.
Yeah, okay, that's good to know. That was why I said, okay, in the regimes of short, medium, and long term. So in the short term, the cost is higher. But I guess that, if you look at the medium, from the medium to the long term, in terms of what you gain by reduced energy consumption, reduced durability of materials, and of course, the friendliness, if you can cause the friendliness of the environment of that structure, even from the shadow price of the credit you can gain from it, assuming you are in the carbon market for those emission reduction. I mean, you can see it's a massive gain, which comes close to what Dr. Adeni just said. Now, I will have a question from Biwene Bozimo. He said the education of professionals about net zero or sustainable or carbon neutral design objectives, methods, and outcomes is necessary. And according to him, it's ongoing. Yeah, and that means probably the scale, we have not reached the scale, it's not been catalyzed enough so that the things that a third is being showcased, we need to do more even across the country. But here's a question. What steps must be taken to make that information mainstream? Okay, not side scooping. So that it is actively sought by the general populace. Just like now you want to, even in the village, almost all the guys who are gone to the university to read building or read engineering, they're practicing, they're building houses for people. Okay, so how could it be done that when they're building a house for you, they will say, okay, these are possibilities, these are scenarios, you can get this low carbon house and all of that. So how can that? Any of you can answer as we are beginning to shoot down. Hello? Yeah? Yeah, let me start with Dr. Gill. I think he's ready.
Okay, yeah. So I'd like to say, that training and mainstreaming is already happening. Mainstreaming is already happening. I know about a few projects in the country. Some international development agencies currently, as part of the Nigerian Energy Support Project program. They're training, different, artisans, faculty within, major guys in different sectors. They're doing some form of training of trainers. That's their contribution to that sector. So I know that's happening. But I think what needs to happen is a wider coordination, rather than have an typical development support, in typical development in the development sector, efforts need to be coordinated, not working in isolation. We need to be able to work with the NUC. We need to be able to work with, the institutes. PIND, for example, worked with the different professional bodies in the Niger Delta, the Nigerian Institute of Quantity Surveyors, the Nigerian Institute of Architects, the builders, and we're still working with them, to see, how much of this can cascade.
Okay, so we need to really expand that conversation and the engagement. Kolo Marcel is raising his hand. Let's have your comment.
Good afternoon. Yeah,
Can you speak up?
I see. Yeah, I'm speaking. Can you hear me?
Yeah, I'm trying now.
Hello.
Yeah, we can hear you.
So I appreciate all the lectures, and what I've seen from the whole exercise is that the force is not being driven from the right place. You cannot alter academic curricula. You cannot make sensitization that are meaningful if there is no policy asking people to think about this or asking people to go about this. The policy should include incentives. It should include penalties, like you made mention of carbon credits. Yes, if I'm aware and it's available, why not I go for it? So it's high time we also meet our regulators. They need to fine-tune the laws that are existing to accommodate this future practice. Because like a colleague said here, we are living into yesterday. We need to live for the future right from now. Thank you very much.
Thank you, Master. You hit the hammer on the nail, and that's the truth, and that's essentially what all the speakers have been saying. The issues of policy has been sticking out. Issue of even CAMA has to be. I think we have a recent CAMA. You know, the Companies and Allied Matters. I don't know the extent to which it has, you know, made a case for companies to have environmental policy that is one of the first things you see when you come into their company, and that showcases how they implement them faithfully. Is very important. And I think from that kind of comment, we will need to also say that from what Prof just told us about NUC, you know, working on curriculum, it shouldn't be something that it will leave for academia only. It should be able to, you know, bring all professionals and everyone who is acting in any area, in any of the sectors, to come to add an input into how we are going to be looking at centuries ahead from knowledge that we have in practice at this time. Yes, any further comments as we are going to be rounding up now? Prof, are you still there? You want to make your final comment as we wind down. Okay, it's like Prof is not connecting it. Are you there? Okay.
I'm with you on YouTube.
Okay. So just your final comments, and especially I would like you. I hope you heard what I just said. So you're on that committee. I'm sure that professionals and wider people who are involved, including consumers, are involved in reviewing academic curricula for our students, so that we can have a wider view for now and in centuries ahead, because that is what even the Arabian countries are doing. And I think we should learn this opportunity to use to do the same. So what is the final comments, sir?
I agree with you on that. Even the NUC recognizes the input of professional bodies, and they have written to all professional bodies, all the regulatory bodies for different professionals, to make their own input on the curriculum. And the professional bodies should know their clients' needs or the gap between what they are offering and what the client is demanding, and they should include that in their own submission. And the university too should have an interface with the industry and find out what the gap between what they are teaching and what the industry needs to fill in this gap. So that question that gentleman is a very, very relevant question, and the contribution made by Marcel is very, very timely, because we are living in the past and we want to live in the future. We have to move ahead. We have to get into the future prepared, not unprepared.
That's right.
Yeah.
Okay, thank you very much. I will also add that, you know, even within professional bodies, many of them are learning some of these things, you know, learning the ropes. So you might actually be recommending to your committee that they should be looking for, these are young people, okay, who have actually gone ahead of time. You know, look for them where they are, and they can make comments that will be useful in strengthening the curriculum of Nigerian universities. Thank you very much. Thank you, Prof, for coming. I hope that we can take this further, especially as you guys do more for the profession and for the industry. I think Dr. Tiwa is coming back. Maybe he stepped out. Okay, let me hear your final thoughts, Dr. Giwa, before Dr. Denny comes in.
All right, thanks. So I think for the sector, for me, what I'd like to see in the sector is more of the, you know, the push and the pull, coming from the central government and the different respective agencies. They already have the equipment, they already have the platform. They don't need any further, push into it. So they just need to provide the incentives on one hand and the enforcement, using the laws. I also like to see the big construction players, for many industries, these days start without the big construction players. The guys who are in heavy, the cement companies, the big construction companies can actually design their own methods. And you'll find a lot of conforming, we're conforming people. There's a lot of the industry will conform after them because they tend to set the standards.
That's right.
And I think with that, we should arrive at, somewhere by 2030.
That's right. I agree with you. And you may want to know that we actually had asked Dangote, the guys in Dangote, to come in. Apparently, they've been too busy to join this conversation, or probably because this conversation is just starting here. I hope that as we move on, they will also learn to come and lead the conversation. And then, like you said, bring their standards to bear. I also want to say that beyond waiting for government to design policy, from just wake up and then sit and begin to either tinker, design, or create policy. I think there is need for advocacy actually. People who are already in this sector doing it need to come together and create an advocacy that will excite policy to mainstream what we're talking about, so that they can work with us, walk the talk with us. Thank you, Dr. Giwa. I think the issue relating to your test structure, we need to take that conversation further and see how we can get you more benefits. I know you like that. Thank you.
We'll be glad to have you.
Thank you. Okay, Dr. Denny, your last intervention as we are rounding up now. Are you in?
Yes, I'm in now. Yes, sorry, I went. Yeah, so my last intervention really is just, I don't want to say we've said it all. Before we get to the situation of engaging government, people are doing the right thing and making money in the international market. Nigerians are doing it and making money. People are doing the right things. Edge buildings are springing up. So before we even get to the issue of policy, it can still be done before the government continues to drag its feet and do the right thing. But just like Dr. Teslim also said, the structure is already on ground. They have the policies. It's just to make it tweak here and there to enforce it. And they are the biggest drivers. Once they make it enforceable, this will have a larger scale. So we continue to do the bits and pieces we can do as we wait for the government. And I'd also encourage everyone to align with this space, because before 2030, we need to get things right. So they shouldn't be left behind.
That's right. In fact, nobody should be left behind. Especially with COVID-19 having dragged people's steps back. I think it's time to go into a leap, because if you don't do a leap, I mean, to retrace those steps that you've gone backwards might be very difficult. I want to appreciate my highly resourceful panelists, presenters. You made my day, and I think that those who happen to make time to join us, when this gets across to them, I think they will marvel. Thank you very much, and I hope that next time we'll call you, because we need to continue this conversation to levels that, to decibels that will be heard across the country, across the region, and of course, globally. You might be interested to know we have participants all the way from New York, because we have been creating global engagements, and it's been working. So next time we'll call you, and I know that you will not hesitate to be on board. Thank you very much. Thank you, and have a great week ahead. Bye-bye.
Thank you. Bye.